This is just a quick rundown of a Python program that I wrote utilizing Python version 3.8. It performs aerodynamic calculations and interacts with another program, GForce 2UI.py, to display all these calculations on the GUI, or the graphical user interface, that you're looking at. I utilize QtDesigner to lay out this GUI. QtDesigner then generates a .ui file that must be converted to another Python program. And this is accomplished on the command line with another program called pyqt6, and that converts the .ui to a .py file. The program itself is a aerodynamic program for pilots or student pilots or anyone interested, if they are, in the correlation between G-force and stall speeds on an aircraft. And the calculations are based on aircrafts that are in level flight and any designated angle of bank that is chosen by the user on the GUI interface. Currently it's set up at 0-degree angle of bank, which is displayed on top here, which equates to a load factor or G-force of 1, which we would expect. And the aircraft lowest stall speed that I have that you can select is 40. This goes all the way up to roughly 149, or I'm sorry, 150. And it can be selected with the dial here. I kept user interaction limited to these two dials rather than them entering any type of speeds, unrealistic speeds via the keyboard. This makes it clean, and there is no chance of any unusable or incorrect data being entered by the user. So all you basically do is select your stall speed and level flight with the dial. Let's say stall speed for the aircraft is 70 knots. As you would expect up here, there's no angle of bank, they're in level flight. G-force is 1, stall speed is 70. As we increase this angle of bank with the knob on the right, you're going to see this stall speed increase. So say I go to an angle of bank of 30 degrees. You see a load factor of 1.15 Gs imposed on the aircraft and a new stall speed of 75 knots indicated. We can then go to, say, 45. You can also click on these ticks rather than dragging the wheel. As you would expect, load factor on any aircraft in a 45-degree angle of bank at level flight would be 1.41 Gs. If their stall speed in level flight is 70 knots, their new stall speed is 83. And let's say we'll take this up to 60. Anyone knows in the aviation community, a 60-degree angle of bank and level flight should impose 2 Gs on the aircraft. And the new stall speed generated here in real time is 98 knots. I have this doing calculations all the way up to an angle of bank of 89 degrees, which is, I mean, obviously pretty unrealistic for most civilian aircraft. But you see the correlation as this starts to increase above 60 knots. There's a drastic increase not only in G-force, but stall speed. So a lot of useful information here for a pilot to play around with. This program was written on an M1 Mac. It is notarized by Apple for the M1 Mac, so anyone can upload this to their computer and should not have a problem running this. It's on my GitHub repository if anyone wants to download that and play around with it. Or you can just actually download it. I believe the DMG file should be there, and you should be able to just download that and run it. Thank you very much.